All right, so we're going to do a quick recap on simultaneous equations. So just to give an idea what's happening. So if you have a linear equation, right? Let me write one that looks this way, y equal mx plus c. Hang on a second, let me fix this up. That kind of look a little too big. So y equal mx plus c describes a line. No, we haven't done much on this, but just know that it gives a description of a straight line. So let me give a piece of a graph and say you have, so this is your y-axis, this is your x-axis, and say this line, so this equation describes this line. Cool? Now, say you have another equation. So I'll call this y1. Oh, I don't know if to call it y. I can probably, so there's another one, y equal mx plus c. Say, all right, let me call that one and call this 2 for argument's sake. Now, this line maybe is like that. You have a line that goes here, right, all the way up. You have another line, right, and the meet right here. Now, when you go through the process of finding the solutions to a simultaneous equation, you're finding the coordinate. Here, you're solving for where they meet. So then we can call it x and y. So you're solving for where they meet. So you will find that you're going to get a question, right? And in the question, they're going to give you pairs or a pair of equations. So let me give you an example. So x plus 2y equal 5. And another one, 3x plus y equal 5. Now, as I said before, we didn't get into saying what C is, what X is, what M is, but briefly, I'll give you an idea. So M tells you the slope of the graph, that is how steep it is. X is just the coordinate on the x-axis, and C is just the y-intercept, so where the line cuts the y-axis. So for example, in this case, I'm trying to draw it a little bit. So here would be a C. So this number would tell you where this line cuts the y-axis. And then down here, now check this out. So I'm going to say the y-axis. So here's another place where this line would cut the y-axis again. So, you know, in how it is written in here, the C's would be out here. So it's just some transposing and they just rearrange the same equation and make it look like this. But we will talk more about that. This is just a high level understanding that you have two lines, two equations, right, that describe some lines, and these equations meet at a point, and that the point that they meet is the solution to the simultaneous equation. Okay? So let me move on and show you how to solve. So you have two ways you can solve. You can solve by elimination, or you can solve by substitution. So elimination is straightforward. Well, both of them are straightforward. What you try to do, you look at it and say, okay, let me see what I can do. Is that if you're adding them. or subtracting them, whichever way you want to look at it. And so what can I do to get rid of one of these variables? So you have your x variables and you have your y. And what you want to do is to eliminate one of them so that you can easily solve for the other. Because remember, if I have a simple equation, say 2x plus 1 equal 5, you know how to solve this. You need to go through the step. So this is a simple equation as a simple linear equation, right? And linear because the variable here has a power of 1, so exponent is 1, right? And you know when it's 2 is a quadratic 3 cubic. But just focus on the fact that all of these equations that you see, they're going to have a power of 1 right here. And we don't usually write 1. We just understand that it means 1. So going back to solving, so this gone, you get 2x equal 4. And then you divide both sides by 2, you get x equal 2. So we know how to solve equations like these. But here, check this out. Here, you have two unknowns. You have an x and a y. And here again, you have two unknowns, x and a y. So you have two equations with two unknowns, right? So it's solvable, but if we had one equation with two unknowns, then we can't do anything without any more information, right? There's nothing else that tells us what we can do with this. But you know, in a sense, it would just be describing a line. Here now, we have two equations, so we can pinpoint the coordinate. So what we do is try to eliminate, as I said, so we can get one variable and then solve like we do here. All right. So what we eliminate now, we see how best we can match up a particular variable. Say I'm going to use the y's. Now, if I were to multiply this equation at the bottom, so I'm going to call this equation 2, call this equation 1. If I were to multiply equation 2 by negative 2, and then add both of them, then you would have 2y here and you would have negative 2y. If you add that, you get 0. So it would be eliminated and you just have the x's to contend with. So check this out. I'm going to rewrite the first equation. And then I'm going to rewrite the second equation, this time with it being multiplied by negative 2. All right, so when I multiply by negative 2, I get negative 6x, I get negative 2y, and I get negative 10. Then I add them. So remember, the only reason for me doing this is because I want the first equation and the second equation to have variables, have terms that look alike, so that when I add them, they get eliminated. So we have, of course, with opposite signs, right? You can either add or subtract the equation. I prefer to add them all the time, right? So you have a plus 2y here, you have negative 2y here. So when I add them now, I get negative 5x here. And this gone, right? You can literally put 0 here. And then this now becomes negative 5. Now, this is simple stuff. This is what we have been doing. So this is just negative 5x equal negative 5. To get x, we just divide both sides by negative 5. And if we create a little more space, we get x equal to 1. Now that we know what the x value is, we need to know what y is. All we have to do from here is to just substitute this value for x in the first equation. It could be in the second equation too, right? Anyone, so you could substitute this value for, you could substitute for x in this one, or even in this one that we would have multiplied by negative 2 to get, right? So we have x equal 1. So we can say, all right, let us substitute x equal 1 into equation 1. So equation 1 is a top equation, which is this one here, the same thing, into equation 1. So when we do that, we get, so, and substitution, maybe we haven't done much on that. It just means wherever you say that value, you put, wherever you say the variable, you put the value that it's referring to, right? So x equal 1. So wherever you say x, you put 1. So 2y equal 5. Right here now, we can solve for y. So just like we would normally do, so let me just fix this up. We would say, all right, subtract 1 from both sides because we want to get y by itself. We're solving for y. So this is 2y equal 4. Then we divide both sides by 2. So y is equal to 2. So if you were to summarize everything we have, so we have x equal 1, and we have y equal 2, right? Which would be the coordinate here that I refer to. So in this case, we would have 1, 2, right? That would be where these two lines meet. And that's it, really. So we can work on another question. Feel free to ask questions, you know, because you guys seem very silent. So if you have any questions.
Sir, if I quite remember, this would almost look like inequalities. It looks similar to when you go through inequalities and then you go to linear programming.
Yeah. So it is somewhat similar to the linear programming. I would say it is somewhat similar, right?
Okay, I quite
Yeah.
remember it now.
Yeah. So once you get the just get how to do this where you know what to eliminate kappa. Some persons, that's a difficult part. Sometimes they
Yeah.
don't know what to multiply by. So in a case like this, it's kind of straightforward because you have 2 here, and there's no way you need to multiply by -2. But there are other questions where it's not so straightforward, right? So let's try one more question that is straightforward, and then we'll try another question that is not so straightforward. And then we can discuss a little more. I'll give you guys, um, I guess you guys could attempt more of the homework questions, which I will reveal to you on the screen, so you don't have to worry about trying to find them. All right, so let me try another straightforward one. So 3x plus 2y for 19, and then x. It's kind of remind me of one of the homework questions. I'm not sure if it's all right. So this will be like equation 1, equation 2. So why this is straightforward is just like the one before, is that usually when you have like a variable have 1 being the coefficient. So here you have 1 being the coefficient, 1y in a sense. You can think of it that way. Here as well you have 1x. These types are simple because in this question, I could have multiplied the top by negative, wait, make sure, yeah, this is the original pair. I could have multiplied the top by -3 and multiply through, and then the x's would have been eliminated, easy. Over here, so you have a x by itself. So to cancel out this 3x, I can just simply multiply equation 2 by -3. And then I just add them, and it finished straightforward. I just add them, eliminate x, get my y, solve for y, and then resubstitute that value for y into one of these equations, and then I will get my value for x. So we can try that, right?
But sir,
Hmm?
sir, you couldn't just multiply it by say one, and instead of using negative, you couldn't just say multiply the top equation by one and the bottom one by three, and then eliminate, and then you
Yeah,
subtract.
you can do that too. You can do that too, right?
Okay.
So it is totally fine that way.
Okay.
Why I like the way that I do it sometimes is that I guess this is best shown by an example.
Mm-hmm.
All right, let me give you an idea. Say I have this, um, and then I have x, and then say this was minus 5y. Now, taking from what you said, right, I could have just said, all right, the top multiply by 1, so I don't have to show that because, it's 1. And then the bottom, I could just multiply by 3. This will be 3x. And then this will be 15y. And I think this will be 45. And then I come like so. And then I put a minus because now we're subtracting, right? And if I subtract, I would just have to remember that I'm subtracting, right? So this would be gone, and then this will become negative 13y. Now somebody will have to help me with this one. This look like what, 26, negative 26? Yeah, negative 26. And then I divide through by negative 13, and I get y equal 2. All right, so nothing wrong with that. That's cool. Now, suppose the question was like this, and I do the same thing where the top one remain the same, and then I do the same thing here, 3x. So I multiply by 3. This will become 15y, and then this is 45. Now, this is an issue that I find happen to a lot of people. So when they subtract, they get this part right. So they'll say, all right, that gone. They come here now. And what they would do is they subtract this and they get negative 13y. Not remembering, that there's a minus sign here that means to subtract
Oh,
everything. So
okay.
this in essence become a plus sign,
Mm-hmm.
right? So this now should become 17y because they have like a minus minus. So what I normally do
Mm-hmm.
sometimes is that I put the minus sign here and the minus sign to remind me that
Okay.
when I say the minus and the minus, that means plus.
Mm-hmm.
And then over here now would be negative 26. So because I know that sometimes persons have an issue with that, I just try and just set it up in a way where I say, here, just multiply throughout by,
My
like the
negatives.
negative, right? Because
Okay.
when you reach a situation like this, when you would have spot it and know, so, okay, oh, the sign that must change, and then
Mm-hmm.
you just add it from there.
Okay.
So at the end of the day, it's whichever one you're most comfortable with.
Oh,
Both will give you the right answer. It's just you just have to focus and make sure that you don't make the mistake. Right?
okay. Okay.
Yeah,
Thanks.
yeah, man. So here now we have y equal 2. All we have to do now is substitute. Let me change this. Just substitute y equal to into equation. Any one of them. I usually look for the easiest one to substitute in. Maybe maybe
Equation two.
2 would be the easiest. Yeah. That's all right. So x plus 5 and then
One.
put in the 2. You could put the y and write out the equation 2 and then you do the substitution,
Uh-huh.
whichever way you prefer. Right? And then now we have x plus 10 equal 15. x is equal to 5, right? So minus not, yeah, 5. So x equal 5. So you have your solutions, right?
Yes.
So we can say x equal 5, y equal 2.
2.
All right. So that's what you do, these straightforward ones. All right. Now to do one that is not so straightforward, let's look and see. Give me a second. So you guys will have to look out for another link soon, okay? So,
Okay.
because the time, so yeah, so look out for another link in the next. I guess this will be over by the next 7 minutes or so.
Okay.
All right. So one that is not so straightforward is something like this now. 2x plus 3y equal 14. 5x plus 2y equal 24. All right. Now, as you can see, there's nothing that you can just, oh, let me just multiply equation 1 by and everything. All right. You literally have to know, look and say, all right, I'm going to multiply equation 1 and 2 by something in order to eliminate the x or the y, whichever one we choose, right? You can't just say, oh, let me just multiply here because you have a number beside the 2, beside the y, you have a number beside the x, you have 5 beside the x. So we look now, and in a case like this, what you can use is the LCM. Basically, the LCM of the coefficients of the x terms are the coefficients of the y terms. So for example, you think of, okay, we have 2 and 3, LCM 6, right? So it's like, it's all right, I can use 6. Or some people that say, don't even go that way. You can just say, multiply the top one by 2 and the bottom one by 3 and call it a day. So some people just think of it that way. So either way um, works. You just know that if you can get this to be 6 and this to be 6, then you
Okay.
can eliminate it. You can eliminate y. Similarly, but this side, if you could get this to be 10 and here to be 10, you could eliminate it by multiplying the top by 5, multiplying equation 2 by 2, right? So that this can become 10 and this become 10 and you can subtract one from the other, right? So let me see how quickly I can do that. So I guess I'll eliminate which one?
Why?
Okay, use it.
Why?
Y. Eliminate y. Right. So make sure you have your calculators ready to multiply these things, the 14 and the 24. So let's ready up. So I'm going to multiply equation 1 by 2. So let me say multiplying. But all right, let me make sure I write that properly. Multiplying equation 1 by 2 and equation 2
By 3.
by 3, right? So what I have here, we'll have 1 by 2, I get 4x, 6y, and this is what,
And
20,
28.
28.
Mm-hmm.
So I can come on, okay, let's put this as 3. And then the next one now is 15x, 6y,
72.
what's this one? 72. Lovely. From here we can subtract, right? Just remember, so I usually put a little minus sign in between them to remind me. So this becomes negative 11x.
Yeah.
D is gone. The next one is, what does this become?
So
That's the question. Any calculator nearby?
28 minus 72, negative 44.
All right, lovely. So negative 44. And then we divide both sides now by negative 11.
Gives you 4.
And we get 4. So x equal 4. Nice. And then we kind of substitute. So I'm going to call this 4. So substitute x equal 4 into equation. And then you can choose one of the one up top.
Choose
You can choose a
1.
simple
Choose
equation
equation
1.
1.
Right? So so this becomes 2
Times 4 plus 3y equals 14.
So this is 8
3y.
so 3y. So this becomes 7.
Yeah.
No,
No, 6.
6.
6
All right. So this y, so divide both sides by 3.
equals y equals 2.
All right. So we have the x equal 4, y equal 2.
Equals 2.
So we finish. So let me end this part right here, and then I send the other link and we'll resume
Okay.
a few.
All right, no problem.